Hello there, it's Jay here from Jay's Vintage Junk, and today we're going to have a look over my my next project, and it's something else for the pet. I mentioned it in one of my previous videos, and it's this. This is a Commodore CBM model 8050 dual floppy disk drive for the Commodore PET. I got this with my other Commodore PET many years ago from a car boot sale. I got this, my 1896 and a printer for £1. Yeah, now it's not in the greatest condition, neither is the computer that came with it. They are a bit rough. My other Commodore PET is actually in much better condition than this. As you can see, it's been stored somewhere damp in the past. It's rather scratched up and it's rusty. And it was supplied by Datalec Computers, Woking, Croydon. Microcomputers, supplies and service. God, I don't know how old that is. Yeah, well, it's like I say, it's not in the best of conditions. I just pull it up to the camera so you can see here. It is an absolute beast, I'll tell you that. It is really heavy. As we can see, we have drive 0, drive 1. Drive 0, there's even a disc in it. Good God. Format 90. That's an old Apple disc that someone's reused. Format 90. I can't think it's going to be any good after being in that. I mean, this has been in my attic for about 15 years, so yeah, I don't think that'll be any good, but I'll give it a try nonetheless. I'll pop it back in there for safety. But yeah, so that drive seems okay. This one, it was like this when I got it. The flap's missing off it, this one. So I don't know what I can really do with that. I was planning on just putting a new drive in there. I thought these were standard. I thought they were just like a 360k PC drive until I started doing some research in this. And they're far from standard. But if you pull it down with your finger, the mechanism actually does still work. So I don't know whether I can, for the time being, find a way of just wedging that down and putting a disc in there and seeing if it does work. I don't know yet. I'll get onto that later. But first things first, let's have a quick look inside. Now, I'd say I have taken the screws out of this already, but to be honest, I didn't have any screws in it when I got it in the first place. So, just like the PET, it hinges up like that. So there we are, there's inside it. And what we've got, let me see if I can just turn it round a bit so you can see. It's so big, it takes up it's like the PET, it takes my whole workbench up. There we go, we can see that inside there. Let me just see if I can just tilt the camera up slightly. There we go. So what we've got, like in the Commodore 1541 and drives like that, they're intelligent drives. So we've basically, this up here is basically a computer. In fact, this has got 2 processors on it, RAM, ROM, everything you'd find in a microcomputer, just to drive the two drives. I can't see anything wrong up here actually, considering how dirty and nasty and rusty the outside of the case is. And I mean, the dirt in here and there's rust in here as well. Even on the Transformer's going a bit rusty, but saying that, it is in my PET as well. But the little micro board up here looks absolutely fine. There's no nasty corrosion on any of the socketed chips. These transistors look nice and clean. I'll test the capacitors. There's not actually that many of them. 1, 2, 3, 4, 5, 6, 7, 8. About 8 capacitors. I'll test them. The crystal up here looks like it may have been replaced in the past, because it's one of them plastic cased ones, and someone's melted it with a soldering iron to solder a ground wire on there. I don't think that'll be done in the factory, so I'm presuming that might be a replacement. Right, down to the drives. Let me just tilt the camera down a bit so you can see the drives more clearly. There we go. Now, I thought these would just be standard drives, but no. we seem to have what, like a master and slave arrangement, where drive 0 here has got all the intelligence on it. That's got the board controller on it. So this will do all the control of the stepper motors, the head. Oh, excuse me. All that things. And the drive 1 seems just like a slave drive. It's got no intelligence on it. Its stepper motors are connected up to this board here. Its heads, which is that cable, are connected up to this board here. So I've never come across that before. I'm not sure what I could really do about it. I might take this. Well, I'm going to have to take this drive out anyway. I have done a little bit of preliminary probing on this thing, and it's dead. It is completely dead as a doornail. No activity on the lights or anything. Now, I didn't fancy keeping it powered up for too long because there's a filter capacitor down there, and it's quite an old one. I don't know that type of capacitor. I've not come across them before, but I don't really want to risk running this on the mains for too long, just in case that goes pop. So what I'm going to do is I'm going to take this drive out. I'm going to take the power supply unit out, because it just unhooks from the board. It's no problem. I can disconnect it easy enough. So I'm going to take that out so I can test it on the bench. I can remove that capacitor and replace it if I have to. I'll do some tests with that. But I'll take the transformer out and I'll run it on the bench so I can measure the AC output. Make sure the transformer's working alright. Then I can check on the board and make sure that I'm getting my voltages out of the out of the power supply. Sorry, I'm struggling a bit here this morning. So I'm going to make sure that that's working. So I'll remove that, measure the AC coming off there. If that's okay, I'll go on to this, the power supply section of the board. So we've got the power transistors there. I'll find out where the output of that is, and I'll measure the outputs on there, make sure that's alright, and basically go that way along on the circuit. I'm not going to worry about this drive for too long for now. I'll get it working as a one drive system with drive 0, and I'll worry about that at a later date, but we'll pull that out and have a quick look at it. Right, in fact I think I'll do that now. I'm going to remove that drive. I'm going to remove the power supply there. We'll have a quick look at the drive, and I'll probably leave the video at that for today. And yeah, alright, let's get on with that then. Ooh. Oops, hope you can see all this. Kick the tripod again. I think this is a rookie mistake with YouTube videos, kicking tripods. Right, okay, now let's see. We disconnect the head there. Right. It's not keyed in any way. It doesn't seem to be. I don't like the idea of that, because you could put that on the wrong way round. I think we need to mark that up. I don't want to just disconnect that. Right, what have we got at the back here? That's the motor. That goes into the motor, yeah, and that's red to black, and it's the same on the other side, so I can unplug that because I can just copy it off the other side. Okay, so that's disconnected. Can I do the same on that? Oh, I can, yeah, it is kind of keyed because it's exactly the same as that one there. Yeah, I can see which way around that goes. Or are we going to, I'll tell you what, let's get a bit of tape. Stick a bit of tape on that side there like that, and we'll stick a bit of tape on that side there. Like that. That'll do, because I can see them and I can remove them at a later date, so I can unconnect that. Let's have a look at these here now. Are they the same at the other side? Yeah, they're identical, so I don't have to worry there, I don't think. I can, yeah, if I follow the same pattern, we should be alright. That's 1, 2, 3. Right, so that's disconnected. 1981 Commodore, made in USA. Right, so I think we can get this drive out now. Let's have a little look underneath. Yeah, there we go. Should be an interesting one, this. It's led on to another project. I've been chatting with someone discussing my pet and about transferring stuff between the disk images between the internet and the drive format that this uses, which is a D80 format. And he was showing me a piece of hardware you can build which will allow you to connect this disk drive up to your PC using USB, which is quite fantastic actually. So I will be able to transfer disk images off the web in D80 format straight onto this drive, and actually be able to put some software on it and then connect it up to my Commodore PET. What I really want to do in the end, if I can, so I've got two PETs. I've got a PET printer and I've got a PET disk drive. It's set like a little PET network up, because with the IEEE bus you can share peripherals. Ugh. Oh, that's nasty down there. We've got some dead things. I think they were once wood lice. They've gone white, they've been there for that long. Right, let's put that to one side. So anyway, I was saying, I'm going to try and get the power supply out now. Right, let's disconnect it there. Ah, right, this is going to be harder than I thought. So that goes over to them capacitors over there. Oh, right, I didn't want to disconnect them just yet. Right. How are we going to do this? I don't want to desolder all them. That's what I could do. Do I want to cut that off and take the whole unit out as one? That's a thought. Do I just cut these off here now? Let's think. Or do I take the capacitors out and disconnect these wires properly? Oh, actually I could just take the capacitors out, couldn't I? Yeah, I could just do that. That's a better solution, isn't it? Right, where's my clips? So I want to test them capacitors anyway. So let's just snip the cable ties. Oh, come on. I don't want to try and damage the outer. Bloody hell, I tell you what, for 30 odd year old cable ties, they're still in pretty good condition. They usually just crumble to bits. But these are, wow, these are tough cable ties, that's one gone. And let's take that one out there. Right, okay, so that should be the capacitors. Yeah, there we are. Capacitors are free, so they can come out with the... Alright, so we've got an earth down there we need to sort out. Unfortunately... Oop. Crowded bench, overcrowded bench. There we go. I've got my nut spinner as well. Actually, I bought a new set because I couldn't find my old cheapy set. These were only £1 from the local DIY place, so I didn't break the bank. Right, where's a holder for that? Oh bugger. Oh, never mind. This is what you get from doing videos when you're not 100% prepared. Right. Now, let's have it. There we go. So, that should do it. Now, take that off, disconnect all them. Right, let's just put that washer and that back on there so I don't lose them. Put that back on there. Put that on there. Okay. Now, put them away for a sec. Find my handle for that. Right, now, should I take the power supply out? I can see 1, 2. I think there's some on the back. So let's take this screw out. I don't know if they go right through in that. Yeah, they do. Oh, hang on. No, I shouldn't take them out. Right, I need to take this one out. If you take the wrong screws out, it's going to come apart in the wrong order. Right, so put that with the other ones. Okay, take that one out. Now I think the other ones, right, I'll have to move that drive. Come on, you come out of the way. Now, yeah, there's 2 on the back here. Let's whiz them out. There we are, that's free now. So, let's get the it's a heavy beast this. I need to bring my soldering iron out of its holder gear and get back in. Right, okay. Now I should be able to remove the power supply. There we are. Oh, wow. How shiny the case used to be once. Actually, it's not that. I think, actually, look at that. This case might, internally anyway, come up really nicely. Yeah, I think that'll come up really nice. Outside I'm going to have to respray, unfortunately, but I think the inside I'll get away with. Right, okay. So I'll put this aside for now, and we will have a look at the items we've removed. So, what have we got? We've got the power supply section with these capacitors. Row. Elco. Oh, they're Elco capacitors. Right. And we've got a date on them. I think these will be absolutely fine, you know. Made in West Germany. They always make very good capacitors. 22,000 microfarad, 16 volt. And they were made in 1182, so I think we can pretty well date our disk drives to the end of 1982, so it's quite a late one really for a PET. We've got another Elco here. This is 15,000 MFD microfarad, 25 volts, again 1182, made in West Germany. I will test these. It's no problem touching the ends of these. If these were high voltage capacitors, you'd never do that because you'd really know about it. But 16 volts and 25 volts, they can't do any harm. They've never been venting or anything. Like I say, I will put them on the ESI meter and test them, but I don't know how much of a meaningful test I'll get with that because they are very high. But yeah, I really don't think they're going to be at fault. But let's have a look at the rest of the power supply quickly. Right, what have we got here? We've got our mains input, switch, a fuse, which I've already tested and there's nothing wrong with the fuse, that's the first thing I've tried. Now this suppression capacitor, which I want to have a look at. The chance of it's made in Germany, I'll leave it in, because they were rather good at the capacitors. And I think this drive was made in Germany. And it's strange, Commodore had quite a lot of European manufacture. I think they made the 64 in Scotland somewhere. I think it was Scotland. It's somewhere up that way. It's on a thing. And they made various Commodore things in a plant in Germany. Right, let's have a look at this. Yeah, it's an X2. It seems to... right. Yeah, it's not just a standard X2 capacitor, this. What we've got is we've got X2... we've got two X2 capacitors and a choke in one little package. And yeah, it is German, West Germany. Can't see a date on it. That can't be the date. It can't be 1965. 83. There we go. 483. So it's very, very old, but I'm not going to be too worried about that. I don't think that's going to be at fault, to be honest. I'll be happy enough to power this thing up. Put that back on there. No signs of distress either. Generally, like on the X2 capacitors, the ones that blow are the ones that are the cases are starting to crack and they've got moisture in them. There was no sign of that in there. It looked absolutely fine. The seal on the end's still good. So I'll put that to one side. I'll probably do the testing of that in my part 2 video, because I'll go over a bit of the safety on how to test things like this. In a safe manner, because you are applying mains to something which is then actually encased, and there are things you could touch and fry yourself. So I will go through that more in detail in a part 2 video. So let's have a look at the disk drive we removed. Right, here we go. Let's see how well you can see that on the camera. Let me see if I can just get this a bit closer. Let's see now. Bring that up a bit. Right, okay. There we are. That's not too bad, is it? Right. So here is the. Well, this is my first look at this as well. Out of the unit. The sides seem nice and clean. Anyway, there's no oxidation on there. The top's a different matte. That's filthy. And we've got some corrosion here and dust. I mean, it's going to need a really good clean. Oh, it's belt drive. Right, and full of dust. Right, what a strange mechanism. There's, can you see this? So we've got. I mean, a lot of early drives were belt drive, so I should have really expected that. Amazingly, the belt doesn't feel in bad condition. The belt actually feels fine. It runs nice and smooth. Yeah, that runs really smooth, and it's dead clean in here. Look at this. Considering that how bad the outside of the drive looked, that is absolutely spotless. Look, really is clean in there. What's concerning me is how the hell do you get to the heads to clean them? That's what I was why I really wanted to look at this, so I could assess it for the other drive to see how I can clean the heads. Yeah, bloody hell, I can't see any way in there. I mean, I guess this must come off somehow, because I mean, well, I don't know. This is such a strange drive. I mean, the whole bottom of the unit seems to pivot when you pull the tab down to lock the drive. That's a really, really strange mechanism for a disk drive that I've never come across before. Interesting. Now, the guy I was chatting to on the comments section did say about wondering whether there was a possibility I could perhaps replace this. Not the intelligence, just actually the bare drives from something else. He suggested a PC high density 5¼ inch drive because of the head compatibility. And I was wondering, these are double density drives as far as I'm aware. I don't know whether a high density drive would be as good. Wondering perhaps what about a PC double density 5¼ inch drive. I've actually, hang on a minute, just 1 second. Ooh, I can prompt you off camera. There, so I've got that. So, could it be possible to, I don't know. Now this has got two sets. Obviously this is a double-sided double density drive, where that's a single-sided double density drive. But that just means that this has got two sets of heads, where that's got one head. I wonder whether it would be possible to use this mechanism to replace that. I really don't know. Perhaps some comments on that. Because I mean, we wouldn't be using the electronics here, we're just using the actual drive itself, its motors and its head. I don't know how compatible it would be. Perhaps it wouldn't work, I don't know. Perhaps it'd be a shame to wreck a full height 360k PC drive. It is an IBM one. It's out of my original IBM PC when I put a 10 meg hard drive in it. It's something I'll think about that. Perhaps probably not the best thing to destroy. Yeah. But yeah. So plan with this, I don't know. See if I can get in there to clean the heads. I can't even see how you get... Yeah. I'm rambling now because I don't know what to say. Well, what I will do, I'll leave it here for now. I might see if I can find some information about this drive, because we do have the part number on it now. This storage module. I've got a model number and who made it. So I may be able to dig up some information on this, a service guide for it, how to clean the heads on it, I don't know. I'll have a look at that, I'll go and do some research online on that. And in the meantime, on my next video, we'll test that. We'll check the capacitors out best way we can. I'm not sure whether my ESR meter can cope with capacitors that big. Let's have a look. How big can it go? 10,000. 10,000 is its limit at 35 volt. Well, that's 15,000. That's 22,000. So it's well over what it does. But at least we'll get some. We'll get some indication. We'll at least know whether it's got high ESR. So we'll test them. We'll hook this up, and we'll test the AC voltages coming out of there. If they're right, we know that our main part of the power supply is working. We can get this back into the disk drive, and we can start probing around on the main board, see if we get the voltage we're expecting. Because I'm expecting there to be well, there'll be plus 5 volts, there'll be plus 12 volts. There's probably a minus 5 volts, minus 12. There might be a minus 5 volts, minus 12 volts. There's probably minus 5. Depending on what RAM it uses on there. No. It might have minus 12 volts on there, I'm not sure yet. I've not dug into it close enough. Right, I say I'm rambling now, so this video is already way long enough, and it'll take me hours and hours and hours to upload it because my broadband speed's crap. Right, so goodbye for now, and yeah, thanks for watching.